I welcome Dr. Parvez Hayat this morning. He is a senior retired DGP IPS officer. He retired as a DGP from Jharkhand. I welcome you, sir. Uh, this is the fourth lecture of this program on urbanization and climate change. Another very important dimension, how this urbanization leads to change in climate. That is, urbanization is one of the key factor drivers of climate change. So I welcome you, sir, and I request Dr. Alex to have this session.
Thank you so much, and welcome back on day 2 of the GEON workshop. So delighted to be here and presenting on this topic. So the breakdown of my presentation today will begin with trends and projections of urbanization. So that's the sort of social demographic side. Then we'll look at trends and projections of climate hazards specific to urban areas. We'll look at a study that I was involved in that we recently completed and are about in the process of getting published at CSUN, my center at Columbia University. It was funded by USAID, and we looked at 2,300 cities around the world, and I'll describe more the implications of that study. Talk a little bit about urban adaptation, and then in the last day, I've gotten some requests to find out more about our NASA CDAC data as it relates to urban areas and how to access those data because it's become more difficult. Some of you have tried and failed to actually get access to our data. As I mentioned yesterday, our contract was terminated with NASA in April, and so we've been working very hard to get the data up in an alternative environment, and we'll talk about that. So what's going on with urbanization? You're all aware of the trends in growth in the percent urban globally. I think there was a big fanfare about a decade or more ago when UN declared that the world was now 50% urban, the population of the world 50% urban. Now, I don't know the exact percentage, but the World Urbanization Prospects, which was last published in 2018, shows India growing in terms of percentage from under 20% in 1960 up to, sorry, is that 60 or 50, to now around 65%. That's Asia. India growing from under 20, really around 15%. And if you follow the red line, it goes up to about 52%. And, in many ways, India is still a very agrarian and very rural country. China, for instance, is probably well up above 80% urban now. So by contrast, you also can see the composition of cities. And in India, you've got, back in 1990, roughly 2 cities that were over 10 million. We now have between 5 and probably 6 cities that are more than 10 million in India, 4 cities that are between 5 and 10 million, and then a large number of cities that are in the 1 to 5 million range, and it's projected to grow even more. So we saw roughly a doubling in the population that's urban just between 1990 and 2018. This is just looking at current growth rates, and what you can see is the sort of distribution of urban growth is heavily centered on Africa, parts of the Gulf region, and specifically China. But you see high percentage growth in roughly 3 to 5% growth rates in a lot of cities of South Asia, in India in particular. So we're in an urban century, as it's often said. We have data sets, and this is one of the ones I'll sort of give you a sneak preview that look at. This was developed with the Joint Research Center in Ispra, Italy, and uses our population grids as part of an input to model population distribution. But this is the part that is called the built-up grid. This is the sort of built-up area percentage by 1 kilometer grid cell. And you can see the percentages are listed on the left-hand side in the legend. But basically from 1975, you can look at these same cities. Let's just focus on, for instance, Kanto region in this is part of the Philippines, and or is it? No, it's Japan. So that won't grow too much. What you'll see is a lot of growth in places like Sao Paulo, in this window here in 2000, continuing to grow. And then if you want to project into the future, we also have data on our NASA CDAC that look at population or projections of urbanization under different SSPs. These are the same SSPs I talked about yesterday in my lecture. And you can see that, for instance, East Asia, by this is up to 2100, under a regional rivalry scenario, this is the kind of least desirable of the different SSPs, you see a lot of sprawl. So there's a lot of growth into rural areas, whereas under a sustainability scenario, it's much more contained. Okay, so let's take a look. We've just looked at the urbanization trends. Let's take a look at some of the climate trends. So in cities, we'll see a lot more extreme heat. So days in which temperatures exceed, say, 30 degrees Celsius, wet bulb. Flooding from sea level rise, storm surge, extreme rainfall, drought occurrence. It's not that cities are immune from other hazards like cyclones, landslides, etc. But I think that these would be the top three. I've already spoken to some of you who have interests in these areas. And this has tremendous implications. Oh, so here's the flooding. Sorry, I had some illustrations here. And drought. We'll talk a little bit more. I have a slide that talks about drought issues in cities as well. So these have implications for the health of the populations in cities, labor productivity, we spoke about that yesterday, energy demand, loss and damage, so particularly what cities concentrate high degrees of built material, buildings, infrastructure, and so losses, economic losses, tend to be extremely high in cities. And then water supply issues are also significant in these cities, and there's a range of other things that we might need to look at. So in terms of heat trends, this is some work that a colleague, a former postdoc of mine, Cascade Tucholsky, has become one of the world's renowned experts on extreme heat. So I know that he continues to work and publish, but this was one of his first publications in 2021 in PNAS, and it looked at trends, basically the increase in the number of person years of exposure. So the idea of a person year is every individual is counted once for every day in which they're exposed to this extreme heat events. Okay, so if temperatures exceed this threshold of wet bulb globe temperature of greater than 30 degrees C. So this is not, maybe some of you say 30 degrees C, that's nothing. But when you get the hot, really hot humidity, it can start increasing mortality. There's other thresholds he used, but for this purpose, I'm just going to show you the work for the 30 degrees C. And so what he showed was that over the period from 1985 to roughly 2016, we saw an increase in average increase in the population exposed of 2.1 billion person days per year. So it's a quite dramatic increase. But some of that increase is just because there's more people in these areas that are exposed, right? We talked about exposure yesterday, and so that's an important variable. So some of that increase is in 1.4 billion person days per year. That increase is from just population growth. The other 0.7 person days per year is actually from the change in the climate, the actual increase in numbers of days of exposure to that 30-degree wet bulb temperature or above. And so he mapped this, and you can basically see what parts of the world are being most exposed. And, it's pretty clear that the Gangetic Plain in many parts of India are an epicenter for increase in person days of exposure to extreme heat. Also, the plains of China and parts of coastal Mexico. Why do you suppose, why do we suppose that some of these areas are so closely clinging the coastline? What's the characteristics that you would expect in those areas along the coast? Does anyone have an idea? Yeah, these tend to be hotter, more humid climates, right? If you've ever been in a coastal town on a 35-degree Celsius day, it's going to be humid, right? And you're going to sense that hot, humid heat much more. So that's why there tends to be this kind of increase in those areas. Clearly desert areas in much of the world are relatively immune from this occurring. So that's the pattern that he showed. Projecting into the future, the World Resources Institute last year produced a report in which they looked at exposure of cities to heat waves of varying intensities, but it goes up to 48 degrees. So the darker the color, the greater the intensity. And they looked at heat waves as defined. Now, those of you who work in extreme heat, urban heat islands, et cetera, you know that heat waves can be defined many different ways. And it's not a settled science in terms of what a heat wave is yet. But as long as you're careful about defining what your heat wave is, then you're fine. In this case, 3 or more consecutive days in which high temperature equals or exceeds the 90th percentile. So it's a relative measure. A heat wave in New York City will not be the same as a heat wave in, say, Delhi, India, because of the relative nature of this measure. But what they do find is that under a Paris Agreement world, you would see an increase of about or roughly a mean of 4.7 days, 4.7 events per year in the future. And in lower middle income countries, about 4.4 events per year per city. So this is the mean. And in an extreme future climate scenario of 3.3 degrees Celsius, we talked about 3 degrees. Remember, I had that burning embers diagram. And once you start getting in that 3 degrees realm, you start getting into a danger zone for many systems. And so the increase would be from 4.4 years to roughly 5.8 years in the lower middle income countries. So that would include India. So there's quite a bit of likely future urban exposure to heat. What about flood? So these are some projections that were, this was actually historic data. So they're looking at the past and looking at exposure to floods in the past, and they showed how, one of the big issues in many countries is you've got urban growth and encroachment into wetland areas and into riverbanks and in wet areas that frankly probably shouldn't be settled in. And so what you see here is where it's red, if you're trying to make out what this, we'll start here and then we'll go up here, but where it's red, it's basically greater than 50% of urban growth or settlement evolution and expansion is into areas that are flood prone. It's 50% above the level that would be under kind of compared to areas that are not flood prone. So it's 50% higher in flood prone areas than it is in non-flood prone areas in these regions. India is only in the 10 to 50% kind of, and again, this is a fairly coarse resolution analysis. You can tell I think they're using river basins or catchments as their units. So if it doesn't look like states of India or whatever, that's because they're using river catchments. But it basically says that a lot of growth is going on in flood exposed areas. And so that's an historic period. In the very high hazard level kind of building areas, upper middle income countries actually see a pretty high percent growth as well. but the highest income countries tend to see much lower growth. That may be because they've already built into those areas in many cases, right? We drained the swamp. We decided, we're going to fill like most of Boston and much of New York, the parts of New York that are built on fill, right? It's just basically they took a bunch of land from hilltops, excavated it, and dumped it into the ocean to make more land to grow on, right? So that, in a sense, we did that historically. But it may also be because zoning processes are a little bit more stringent in some of these countries. So they would try to avoid having growth into areas that are likely to be flooded on a frequent basis. FEMA, the Federal Emergency Management Agency in the US, issues flood zone maps of 100-year return period floods. And that tends to be a red line, in essence, a place where you're not supposed to start building into those areas. What about projections? So if you project, this is a relatively short-term projection that was done a few years ago by a colleague, Barak Gunneralp, at Texas A&M, I believe. Basically, they looked at future growth by 2030 in the low elevation coastal zones and in other areas that are flood prone. And they forecasted the amount of urban expansion in three flood frequency categories by geographical zone. So you have low frequency flood risk, medium frequency flood risk, and high frequency flood risk. And they found that projected growth in India was actually, kind of close to and catching up with with China in terms of it exceeds any other country on the map in essence for, projected expansion into areas that are likely to be flooded. And I believe it's largely because of the coastal development in India. So this is a common occurrence in many parts of the world. Shanghai obviously is not exempt either. You can see Metro Shanghai here. And they've just been building in areas that are, extremely close to the ocean and in danger of future sea level rise and storm surge. Okay, lastly, let's turn to drought. And I'm just giving you a sampling of some research out there. Barak Gunneralp did the same for drought, and he looked at growth into drought-prone areas, expansion into drylands, and India shows up here as mostly growing in areas that are semi-arid, not so much into hyper-arid areas. But I believe this is North Africa, and you can see there's quite a bit of growth into hyper-arid areas in North Africa. So, we can slice and dice this in different ways. Last study that I'll pull up here was one done by other colleagues of mine. Gordon McDonald led the study, but I believe that one of my colleagues, Deborah Bulk from Season, when she was still working with us, was involved in this. And basically, it looks at the spatial distribution of cities greater than 1 million and their water shortage status. And here the key, if you can't read it, orange areas are perennial water shortage in 2000. So this means that already there's a perennial water shortage, and those are largely in the Gulf, in Western Asia. New perennial water shortage, these are the ones we should be looking out for, are in red, and there's just another one in the Gulf, one in Africa, in a few smattering cases. But basically, seasonal water shortage is the big issue by 2050. You can see a lot of purple dots here. Dark purple means by 2050 we expect to see more seasonal water shortage. And I think the implication is if you're already experiencing it in 2000, by 2050 you're likely to continue being exposed to these issues. So India shows up as having a lot of exposure to this seasonal water shortage issue. And so this brings me to my last slide describing the work of some other colleagues. And it looks at, for instance, zero water days. This is, you've heard of these zero water days. From what I understand, I didn't actually realize it, but just last year, Bangalore had an experience of a zero water day. I think there's some colleagues from Bangalore. Yes. Were you there at the time? And what was it like? Did you have any problem accessing water yourself, or did it pass eventually with the monsoon? They rationed the water some. So there was some water rationing going on. I actually queried my climate science colleagues from Lamont about the drought in Sao Paulo. So I have colleagues who work on climatology in Brazil. And what they said, so they gave me some maps. So you can see for the 2015 Sao Paulo being the largest city of Brazil, right? So it's a very important mega city with huge financial center. You can imagine if you run out of water in a place like Sao Paulo, it's a crisis. You know, what are you going to evacuate people? You might have to do that eventually. So they describe the drought as being pretty severe, but they gave me also, I didn't put it up here, but they gave me a chart showing drought over a 50-year period. And it clearly showed that droughts were cyclical and that, in fact, the city had experienced similar levels of drought in the past, but the city had just grown so much on the one hand, so demand had increased. But the other thing was that they hadn't been managing their reservoirs. So this looks quite catastrophic. This is the reservoir in Sao Paulo. But if you don't actually regularly dredge and pull sediments out of your reservoirs, the capacity of those reservoirs to hold water declines over time. So, you know, sedimentation will just build up and you'll have less and less volume of water that's being retained. So that was part of the issue in Sao Paulo, is they simply hadn't been maintaining the infrastructure. Now maybe, and I hope 2015 was a wake-up call for them and they actually said, uh-oh, we better start doing something about this. And then most of you had heard about the Cape Town case in 2018. That was pretty dramatic. And they really, I think it was a much more severe scenario in Cape Town. So again, cities are kind of on alert now that if your water infrastructure does not is not up to snuff, is not keeping, you know, holding enough during the wet season, then you're in great danger of running out of water during. And you know, California has had some similar incidences as well, where the water levels in the reservoirs. Most of Southern California relies on water from Northern California, and they rely on water that's actually coming off the Sierra, the mountains. Okay, so these are mountain chains in Eastern California that capture snow melt mostly, and then it melts and then refills the reservoirs. And the big issue in California is that snowpack is decreasing over time. So snowpack in western United States means water during the dry season. That's essentially what it means. And the less snowpack you have, the lower the volume of snow, then the more issues you're going to have during the dry season. And this is happening in many parts of the world. Okay, so but what you see here, I mean, the map is clear. Changes in temperature clearly over the 1950 to 2015 period. And the SPEI during this 2014-2015 period was exceptionally high. And this is right where Sao Paulo is, right in there. So they were in the epicenter. So my early experience in working in this area was a paper that I wrote with colleagues. We actually wrote it in 2001 or 2 when I first joined Season. I got connected with some colleagues at Clark University, another geography powerhouse in the US, and they invited me to join them in a study that would look at 3 cities. The 3 cities, Rio de Janeiro, Mumbai in India, and Shanghai. And what we wanted to do is look at the degree to which different systems, the physical environment, infrastructure, endowments of the cities, and direct and indirect coping capacities allowed these cities to overcome potential climate risks related to temperature change, extreme rainfall, drought frequency, wind speed, sea level rise, and other stressors, including population growth, economic downturns, and globalization. So it was fairly comprehensive. We used a framework that's called the Extended Vulnerability Framework. If you read yesterday, I signed one of the readings was my first chapter of my dissertation. And in there, we talk about an extended vulnerability framework developed by Billy Turner et al. It was published in PNAS in the early 2000s. So we use that framework as a way of systematically looking at the risks and vulnerabilities in these different cities. And I should have gone back and reread the study, but what I remember about the Mumbai study, this was actually conducted a little bit prior to the Mumbai floods, so we didn't have the 2005 floods as an example. But what I do remember about it is, in Rio, we highlighted political fragmentation and the fact that the mayor and the governor were of different political parties, and so that hampered any action. So there are a lot of political factors that limit the ability of local municipal officials to actually act on certain things. Currently, we're just working in Rio. I was there in December, and we were conducting a workshop on slum or favela, risks to climate change and vulnerabilities. And I was informed that they had a center from the Rio Global Centers, ran a climate hub, and the mayor had been funding it. Well, the mayor now wants to aspire to be the governor of Rio State, the state of Rio de Janeiro. And so he decided to drop climate change. Even though they're going to be hosting the next COP and all the rest, he wanted to make sure that he came across as someone who's a law and order guy. He wants to bring security to the city of Rio de Janeiro and to the state. So he decided to drop climate and focus on crime. And so this is interesting. These are the kinds of things that once you get close to the ground, the more you learn about cities and the issues that are going on there. It's all about politics often, what goes on. Mumbai, I don't know anything about the politics, but what I do remember about our study was we looked at Slum Dwellers International and other groups really came out of organized movements in the slums of Mumbai, from what I understand. And so the degree of social organization within slum communities was quite high, and that was something that we noted in our study. In Shanghai is much more of a case of top-down central planning, where the government basically organizes everyone into brigades. If there's a crisis or whatever, people are tapped to basically, they're deputized. It means you take someone, an average citizen, and you make them into someone who will work in the context of, work in a disaster context to help organize the population. So they had a much more centrally planned approach to addressing climate perturbations. Main findings. What we said, we applied a selection of data identified by a vulnerability framework. We didn't obviously have complete data. We could only I went to Rio de Janeiro and I visited one of the favelas. That was as much field work as we were able to do. I've subsequently been to Shanghai and validated some of what we studied. But we used this vulnerability framework and we looked at stressors on the climate side combined with physical and social characteristics. One of the things that I think is important to realize, and we can talk more about this today and in the solution space, but one thing that concerns me increasingly is that a lot of these disasters that will happen, that are happening and will happen in the future, are essentially unequally distributed public bads. What does that mean? They're not goods. They don't really generate revenue. There's no real good that comes out of them. These are things that happen and generally cost money. And so the local financial, the public purse is strained every time another disaster comes along. Disaster response also, interestingly, is something that can have political repercussions, right? So if you don't do a good job responding to a disaster, mayors are often held to account and they may be voted out of office if they don't. But this issue of disasters affecting largely more poor populations, more vulnerable subpopulations that have the least political influence is something that we highlighted as a key issue. On the other hand, to do something about them, this is a public good issue that requires financing and adequately functioning institutions. And so you've got this essentially disjuncture between a disenfranchised population that may be disproportionately affected by disasters and public officials that maybe be more beholden to wealthy constituencies. Let's put it that way, okay? Not to put too fine a point on it, but this is going to be increasingly a fundamental issue. I remember soon after we published this, I went to a climate-related meeting, and someone who was studying the issue it might have been Bangalore, but it was one city in India, and I don't want to call it out necessarily, but she said one of the responses of public officials is basically, oh, those people shouldn't be living there anyway. It's like we shouldn't have these people living in these flood-prone areas. So it's sort of blame the victim instead of actually doing something about proactively avoiding flood risks and things in slum and in low-income areas. And then it's basically this issue of long-term time horizons versus a short-term political expediency that's needed. Exigencies, I will call them, exigencies of dealing with short-term crises. And then finally, there's the real risk that the wealthy exit the system. What does that mean? Well, in the US, what we're seeing is a growth, like in response to crime, people live in gated communities if they have enough money. What is a gated community? You know what it is. You have to go through a gate to get in there, and the only people who are allowed in are those people who have, residency or have a visitor permit or something. So in similar ways, the wealthy will build in more disaster-resilient locations and leaving other people to kind of fend for themselves. All right, kind of dismal, I'm sorry. It doesn't sound like you guys have a kind of glum look on your faces, but just to say, these are some of the political reality. I think, some of you know this is what's going on in your cities where you live already, so it's not news to you. So let's turn now to this study that was done. We did it under funding from USAID. As most of you are aware, USAID has been shut down in the subsequent time period. A lot can happen in about 6 months. Literally, we finished this study about 6 months ago in December last year. So, we were fortunate to get it completed, or more or less completed. We've actually subsequently extended the work that we began with USAID to all cities in the world. So we now have a data set for all cities, and we'll be releasing that soon. And it's been submitted, the actual paper has been submitted to NPJ Urban Sustainability. So what were we asked by USAID to do? And here, I'm going to just double check my time. Dr. Rahman knows how I tend to go on and on and on. So, so we were asked, they were particularly interested in how, how various environmental stressors would affect populations living in low-income communities in, for lack of a better term, slum or informal settlements, okay, in low-income parts of the world, low to moderate-income parts of the world. So they wanted to know, what the populations in each city they wanted to know the location of the parts of the cities that are, in these slum areas, and they wanted to know the percent of population that are both in these low socioeconomic status. We call it SES, socioeconomic status, low socioeconomic status, and environmentally vulnerable areas. This is not a term I chose. Remember, I said yesterday that people use terms loosely, and I don't like using vulnerable. I said this is environmentally exposed areas, not environmentally vulnerable. But, anyway, let's just use the terminology that they gave us. And the environmental vulnerabilities that they wanted to look at included heat, so different unsafe high temperatures, unsafe high wet bulb globe temperature, that's the hot humid heat, warm spell days, water scarcity, exposure to cyclones, storm surge flooding, riverine flooding, storm surge flooding and riverine flooding, and then air pollution. And what, the basic approach was you take a city, you divide it up into high and low socioeconomic status areas, and you look at the past vulnerabilities, And then we also looked at the vulnerability to future climate risks. But for that, we didn't have high enough resolution data. This is a critical issue. When you start projecting, right, we talked yesterday about when you start doing projections, a lot of the projections tend to be fairly coarse resolution. The grid cells are too big. So we ended up just using the city as a unit and looked at future vulnerabilities of cities. And that future risk was in a similar set of categories. All were similar to the ones that we used for the historic period, except we also included future landslide susceptibility. So let's take a look. And then they wanted a report card like results, okay? So stacking up, and you're going to see in a minute what these report cards look like. But let's walk you through the steps it took to develop this first. So what we did is we segmented each city into low and high economic status areas. One of the things that's really amazing is the development of all these global open source data sets, right? So we now have OpenStreetMap, and we have something that, what was the name of it? I'm always forgetting it. It's coming to me, but it's a global, basically building footprint data set. Does anyone remember the name? I got it, but it's not coming to my head. Anyway, I can look it up, and it's an incredible source. So they actually merged together Google footprints, Microsoft urban building footprints, and a number of other such, including OpenStreetMap building footprints, and they try to validate it, and they take the best of those data sets. So what we did essentially, and I'm saying we loosely, I mean, it was really Dana Thompson. She came up with the idea, and then we hired a consultant to actually implement it. She segmented this. This looks like a pentagon, but this is just an example, right? So you have the urban street network, which is basically these red lines here. Those are the streets. And then what you find is that if you live in an area that is disconnected from the street network, so based on the location of the building footprints, these being the housing units, she could divide up each city into Voronoi polygons. Voronoi polygons, you know, Dr. Rahman, basically it's a GIS manipulation. For me, I don't know how it does it, but it just finds the lines between each of these points in a way that, you know, kind of optimizes, makes sure that it's between the 2 points. And so all this area here would be considered low socioeconomic status according to this definition. They also divided up the cities using uncrossable features. So uncrossable features are things like water bodies, rivers, and lakes, and also major roads. So by doing that, you basically divide up the city into neighborhoods. And each neighborhood had to have a minimum of 500 people. So they could take the population data and marry it to this, and they could actually measure the number of people living in each of these areas with some level of accuracy. I'm sure there's a certain amount of uncertainty. Here's an example for Alexandria, Egypt. Many of you know that Alexandria is in the low elevation coastal zone, right in the delta of the Nile Delta. So this is the Mediterranean Sea. And the areas in red here are depicting areas that are considered to be low socioeconomic status areas compared to higher socioeconomic status, maybe more planned areas up here. So you can generally see that, yes, there's lanes and pathways between the buildings, but there's not like an organized road network in there that's linking those neighborhoods to the larger city. Probably most of you have been in these kind of neighborhoods, right? Okay, so this is an example of how validation, it's an imperfect validation, but it is a validation that we tried, which basically looked at this low socioeconomic status areas that we identified using this metric of inaccessible, non-connected neighborhoods, compared to validated slum data that were developed by local community-based organizations or government agencies in different countries of the world. And you can see there's a pretty high correspondence, not perfectly, But we would also not expect all these low socioeconomic status areas necessarily to be classified as informal settlements and slums. All it means is that they're very densely settled and generally, probably a slightly lower socioeconomic status than other parts. I mean, in Lagos, you could say there's much more dispersion and maybe not as much correspondence, but generally speaking, there's a pretty high degree of correspondence here. Whoops. Now, by the way, you can go to this collection, and I'll talk more about the data that we developed for this project, if you like, at the end. But the data are going to be published, and already that low socioeconomic status data set, global data set of all the cities of the world, is already available and can be accessed through the Harvard Dataverse. All right, so this is an example. I'm going to run through Indonesia because I didn't have as many slides to show India, but I have a few on India towards the end. So bear with me. And how are we doing? I've been going for 44 minutes. So this shows Indonesia, and basically there's a lot of big cities in Indonesia. It's also a region that's a country that's highly exposed to a range of factors. You've all heard about Jakarta, some of the flood issues. A few years ago, we were looking at the flood of, I think it was New Year's 2021 or 2022. My gosh, it was like Mumbai. They just got a deluge of rain, and we were looking at displacement issues in that case. But so this is the context. And what we did is we took, just as an example, one city called Cilacap, and we looked at the different levels of exposure to past climate exposure, some of it's climate related, some of it's air pollution is the only one that's not sort of climate related. But extreme heat, not so big an issue in Cilacap. So all the area of the city is blue. Maybe one little corner has a red area of extreme heat. Water scarcity, it's apparently a big issue in Cilacap. Cyclone winds, not so exposed there. Storm surge, a bit of an issue in different parts of the city. You can see, both on the coast, but also up in these bays and inlets. Riverine flooding is much more of an issue, widespread within the city of Cilacap. And finally, air pollution. I'm not sure why it's here. Maybe there's prevailing winds that push it up against some hills or something, but that's an area that's considered to be of high air pollution exposure. Just to be clear, we had so many variables that we just had to set a threshold for each variable. So the thresholds were things like exceeding 10 micrograms per cubic meter between the 5 years, 2012 to 2022. So that meant that, if during that 10-year, it says 5+ years, so it means that there were at least 5 years in which this grid cell exceeded, in this 2012 to 2022 period, 10 micrograms per cubic meter. That's the WHO health standard. Okay, that's actually pretty low. I think in India, what is it here? 50, 60. 350, yeah. It can peak, it can spike, right? It can spike. So anyway, where was I? So each of these is based on a threshold approach. We couldn't go and take, different categories of exposure because we had too many variables to play with. But, riverine flooding, it says areas affected by seasonal riverine flooding 1 or more months per year in the data set. All right, so this is kind of overlaying. I just hit something. This is overlaying here the slum areas or low socioeconomic status areas of Cilacap, the water scarcity, the storm surge, the riverine flooding, and the air pollution all together. And I'd mentioned yesterday that, one of the things around social vulnerability is that people who are less favored, who have less power or clout, who are less economically privileged, tend to be forced to live in less safe areas. This is really about urban land and property and economics, right? If you can't, the closer you are to the central business district and to where things are happening, the higher the rents, right? So if you want a low rent situation, you're going to be forced into an area generally at some distance. And often people make a conscious trade-off between hazard exposure and riskiness and distance to their job. You say, well, I could travel 2 hours every morning by, Matatu or whatever the name is in Kenya, and arrive at work exhausted, or I could live 45 minutes and live in an area that's flood prone and frankly crime prone and not very nice in many other respects. So these are the kinds of trade-offs that people have to make often. They often have less durable housing. They have fewer resources. They may be excluded both socially and politically. They may not have as much information availability about what the risks are in the location that they're living in. We talked about education as a surrogate for experience yesterday. Education is a surrogate for having experience with different hazards. And so if you're not well educated, you may not know about or be as prepared for some of the risks. You might not have that impetus like, oh, I better listen to the radio because it's raining really hard now, because I know that there'll be early warning messages saying that I should get out of my house quickly, and I better have all my possessions prepared in a way that I can leave quickly. Those are sorts of things that you need for preparedness. And so, and then of course, when a disaster strikes, there's often catastrophic impacts on housing and on livelihoods. So, you lose days of work, et cetera. You can't get to work when you're flooded. So there are a lot of issues that arise from these extreme events. So I told you just a moment ago that there are these various thresholds that we use and we did in fact apply low to high thresholds for future climate risks. In the past, for the past climate risks, we looked at only one threshold, but you can kind of see it goes by sort of low for cyclone winds from category 1 to category 5. And then, all of these are gradated from low to high. And so what we did is we then summarized the results by city and then by country. And so the city results are shown here for a sample of cities in Indonesia. And what you see is that here we look at the low socioeconomic status populations that have 1, 2, or 3 plus vulnerabilities or exposures, and the first three cells is 50. First three cells are increments of 50, 100, and 500K, and the remaining are 1 million. So this is 50, 250, 350. I'm sorry, 50, 150, and then 650, and then it goes 1 million, 2 million, 3 million, etc. So you can kind of count the cells in that way. And basically, you get a total number of people who are vulnerable also listed here. So Jakarta has something like 11 million people in its population of 41 million that are socioeconomically low status. And then you can see that, at least in Jakarta, there's at least 50,000 people who have 3 environmental vulnerabilities, and the rest of the population typically has 2 environmental vulnerabilities. So that gives you an idea. Some of the cities are simply less populated and also have less exposures. So Makassar only has low or 1 social environmental vulnerability for each of these population segments. So generally lower risk. Then looking at the future risk side of things over on this side, what we see is that heat risks are really high in Madang, and future projected heat risk in Palembang, also pretty high in looking across at Tegal, and then you have very high riverine flooding in Palembang. So I don't have a map right now to show you where all these areas are, but you get the idea that many cities, Jakarta will have an increasing risk of water scarcity, for instance. So these are some of the risks that these cities face in the past and in the future. And that's Silicap just pasted in at the bottom here. You can see it's a small city with relatively few risks, but heat risk in the future is something that's going to be significant. Being, again, a coastal tropical city. If you look at all the countries in Asia, now this, when we did this originally for USAID, India was not included because India is not a USAID recipient country. So they wanted only countries that received USAID assistance. And so you can see Bangladesh, Pakistan, Vietnam show up as extremely high numbers of populations that are exposed to 3 or more environmental vulnerabilities in the dark red, and then a lot of future exposure to things like extreme heat, water scarcity, and even riverine flooding in Laos with a large national level number of people exposed. Let's look at Calcutta as an example. So this is just pulling out some results from this in-press article that's being reviewed right now. And what you can see is the low socioeconomic status neighborhoods of Calcutta. Who's from Calcutta? Okay, so we have 4 or 5 people. 5 people here. Does this seem to correspond with your understanding of areas that are low socioeconomic status in Calcutta? Now, you can be honest. If there's areas missing, you can tell us. Again, we'd want to do more validation when you start drilling down into an individual city. But this gives you an idea of the populations in these low socioeconomic status areas of the city. Then you can look at every one of these is at the highest level of exposure. So the whole city is exposed to warm spells, extreme heat spells, water scarcity, cyclones, and high particulate matter. Does that correspond to your understanding of the city? Okay. And then this is just storm surge flooding. I'm not quite sure why storm surge extends in here. It's along a river. Thank you very much. So we have local geographic experts. And then exposure to seasonal riverine flooding, maybe similarly along river bodies in some low-lying streams. So then you can look at different cities so these are just 3 major cities. I didn't include Delhi because I was kind of interested in the more coastal cities. But you can see the past exposures to various environmental stressors with kind of low end on Mumbai, medium in the case of Chennai, and then quite extreme risks in Calcutta, right? And it's basically looking at, these are sort of fractions of the low socioeconomic status population that are exposed to these relatively high stressors. I'm not sure why, I have to actually ask them why storm surge flooding shows up as not, maybe if you go back here, if you look at the areas of storm surge flooding, it may not be intersecting as much with the low socioeconomic status portions of the city. So I'm not sure. Again, when you do this stuff on a global scale, using global scale data sets, it's often, you need to really go and drill down and maybe use better data when you get to the local level. Obviously, you want to do that. And then for future risks, you see some of the risks: extreme heat, hurricane force flooding, and seasonal river flooding. And you can count up and get a percentage of the population that's affected in each city. So really high percentages with 2 or more climate risks and future climate risks in Calcutta. And then India as a whole, you can see a sort of sum of the exposures in cities. So that's, I don't want to go into this a lot more, but I just wanted to share that with you. Let's see what we're doing in terms of time. It looks like I'm about at time almost. So this is just sort of the high level summary of some of the results for Asia. As I mentioned, when we first did this work for USAID, we didn't include India. But we do find that 5 countries at that time when we did it and excluded India have more people in high socioeconomic vulnerability categories than all of Africa combined. So just 5 countries in Asia have more people living in low socioeconomic status areas than all of Africa. The greatest climate risks tend to be from extreme heat, water scarcity, flooding, cyclone winds. So this gives you a little flavor for what we did there. I'm going to skip through this is mostly motherhood and apple pie. I don't think anyone who's studying extreme heat or any of these issues wouldn't agree with this stuff. But, things like having green space and cooling centers are important for mitigating extreme heat. This is a data set that we produce that basically looks at the availability of public space, urban public space for all cities in the world, and we used data on greenness and green areas for each city. So some cities I'm sorry, it's sort of inverted. So the most at-risk cities are in yellow, orange, red, and they have the lowest percent urban public space. But places like Sao Paulo have a lot of green space. But Lagos is relatively less. Other things like dikes for flood risk, dikes, physical infrastructure, green infrastructure, bioswales. There's a big emphasis now in New York on using things like living reefs, corals, and not so much coral, but oyster beds and things like that to protect the coastline. Clean trash from drainage ditches. A big issue in informal settlements is the accumulation of trash. I think you know that in Bangladesh, they outlawed plastic bags because they were clogging the drainage networks so much. Water scarcity, providing water points, safe water points is a really important issue. So you need more piped water into these vulnerable areas. And then some of the benefits of a geographic approach, which I'll skip. So people were asking about our data. I did say I would put the slides up yesterday. I'm going to put them up immediately following this lecture because I didn't have internet access in my room, but the slides are ready and I'll put them up. So this will be up there. Basically, as I said, we're moving all of our data into the Harvard Dataverse. For now, what you need to do is use this search here, and I'll give you an example right after if I can get access to the computer here. By clicking on this link, you can see what you will get as an interface, and then you can search for these data sets. So if you see URLs in the subsequent slides, those URLs are no longer valid. You have to go through this at this time to get the data, and eventually you can go here if you prefer. I also wanted to mention, I was planning to use data from this Shrug database, but if you're not aware of it, it's a really great resource of data for India. So it compiles a lot of important subnational data on rural and urban characteristics. So these are just different urban-related data sets that we have at CDAC categorized by different things like air quality, location and size, heat. Just going quickly through some of these because I've run out of time. We can look at the Global Rural Urban Mapping Project. This is old, so don't use it. I'm not encouraging you to use it, but I just wanted to say it was one of the first data sets. I think it had 60,000 settlements worldwide with populations over 5,000. We use urban nighttime lights. So we use urban nighttime lights from Defense Meteorological Satellite Program, and we basically just map the size of the city. So you can see the actual footprint of the cities. This is, again, an early data set, not to be used, but just to show that we were early movers in this space, working on mapping settlements. So now this is a data set that I would encourage you to use, and it's a new data set called the Global Urban Points and Polygons data set. And the beauty of this data set is you have population going back to roughly 2015. You have a lot of settlements, 125,000 almost settlements globally with names associated with them and with their populations. JRC, the Joint Research Center, provided the foundation for a lot of this work. They have something called the Global Urban Centers Database, but they only include the largest cities. And so we wanted to include cities that were below that immediate, largest size cities. So we went from, they had about 13,000 cities worldwide. We went to essentially an order of magnitude higher, almost 130,000. This is the Global Urban Centers database. As I mentioned, this is the one that we built off of to produce the data set I just mentioned. One of the nice things that they've done recently is they've added data. So this is not our data set, but it's their data set. But one of the things they do is I mean, we worked with them on it, but it's kind of their product, is they added a lot of climate-related variables. So if you wanted to pull, really for quick analysis, pull a bunch of data on climate-related risks and vulnerabilities in cities globally, this has a lot of those in there already. This is a data set that shows change in urban extent in urban areas, and it uses the kind of band approach, red, green, and blue bands. So the latest areas of growth are in red up to 2013. This only goes for a period from 1992 to 2013. But you can see large areas of urban expansion, particularly in the northeast parts of India. And then other urban expansion projections, I mentioned that earlier. This is an example of urban expansion in southern Florida, an area that's by 2050 still expected to see a lot of urban growth, even though it is at very high climate risk. Global grid of probabilities of urban expansion, I mentioned earlier. This is a data set by Karen Cito at Yale University. This is maybe relevant. It's a little dated, but we use the GRUMP data set. We basically took a 10-kilometer area around each city, and we measured the land surface temperature between the urban core area and the peripheral areas around the city. And that difference is measured, we consider to be the urban heat island effect. So you can see, like, New York has a greater than 3 degrees Celsius difference between the urban areas and that kind of, it's not even New York, right? It's the huge expanse between Washington, D.C. and New York. You see a big difference between the urban temperatures. We did it for both nighttime and daytime land surface temperatures using MODIS data. This is actually a much more sophisticated analysis using MODIS, land surface temperature. I thought they also used Landsat or Aster, but anyway, they go down to a sub-city level. And this is K.C. Chakraborty. He worked with Karen Cito at Yale, and so he allowed us to disseminate this data set. And it's a pretty nice data set if you're interested in. I already mentioned this. This is Cascade's work. You can get this from the NASA CDAC. And finally, we have these SDG-related indicators related to urban public space availability, urban access to public transport. And the methods are all clearly described in the documentation. So this is something we put a lot of emphasis in, is having clearly documented data sets, because you need to know what you're working with. PM 2.5 concentrations by city. This is a data set that uses some of our global air quality data and looks at changes in air quality for cities around the world. So with that, I'll stop. I'm sorry I went over a little bit, but I think we have time for some Q&A. Maybe while I entertain a question, we could also bring up the slide. Could we, is that connected to the internet or not? Okay, so I'll give a demonstration quickly of how you can search for some of our India-related data sets on CDAC. But if someone has a question, feel free to raise your hand. And so there.
Hello and good day to you, sir. My question is, there was a slide that showed heat wave is closely related to low-income countries. But in the recent news, we can see that US, Europe, and Australia encounter a lot of heat waves, which are high-income countries. So how can we correlate low income to the heat wave?
Yeah, so just, I'll get around here so I'm not hearing myself through the speaker. To be clear, the study that we conducted was focused on low and moderate income countries because that's what USAID was interested in. In no way was I implying that countries in, like we know, for instance, in 2005 or 6, Paris had a very severe heat wave in which there was very high mortality. And there have been extensive studies looking at what happened. Why did people die? One is that much of Northern Europe doesn't have air conditioning, so they never had the history of having air conditioning. This is a relatively recent adaptation that they're implementing. I was just in England, my sister's place. She lives in York in sort of northern England. No AC and no fans either. There wasn't a single fan in the place. So, this is kind of have been historically not used to having that, and then once the heat wave comes, they're unprepared. There was also in the Paris case, and again, each of these cases is particular. Similar things happen in Chicago with a high heat wave. Basically, there's a lot of elderly people who were isolated socially. Nobody was looking in on them. It happened that the heat wave in Paris was during the peak vacation time when everybody leaves Paris. So Paris basically vacates in August. Everybody goes on vacation. If you're poor and you're elderly, you're home. Nobody was really checking in. So these are kind of social. Remember, it's really important. I'm always going to bring you back to the social and cultural dimensions of what goes on, because each of these cases has very particular roots in kind of social cultural practices and the ways that we either do or do not look out for our neighbors, social cohesion, things like that. I think you had your hand up, and we'll get one more.
Thank you for this lecture, sir.
I'm listening.
Okay, sure. My question is in extension to the unequally distributed public bad, which you mentioned in the earlier initial slides. Sir, the climate change induced natural disasters, are the cities like London, the primate cities particularly, like London and Paris, are they the original catalysts of climate change induced natural disasters? Or is it urban agglomeration or conurbation out of these three? And if we talk about the trends in the 21st century, like the past 25 years particularly.
So is it the growth of the urban conurbation, or that it's exposing more people? Is that what you're asking? Or just sorry.
My yes, sir. That's why I was waiting for you to. I'll prefer to wait and again ask my question.
I'm sorry, I thought I could multitask, but like most
No, I was
I'm
waiting
not
for
very
you.
good at it. So I'm all ears.
Yeah. So my question is that in the last 25 years, the 21st century trend, if we talk about the climate change induced natural disasters. So when it comes to urbanization, I want to have a mental map of which cities are actually the catalyst of it. Are these the primate cities like London and Paris, or is it urban agglomeration or the conurbation? Because I want to relate it to New Delhi, because we have NCT here and NCR, and Gurgaon and Noida are completely disaster proof.
Okay, so one of the things I didn't make clear earlier is that a number of the data sets, including that global urban centers database and the global GUPTI, what we call GUPTI, the global urban points and polygons data set, are based on definitions that are essentially agglomeration, and these are and this is often an issue, because if you start doing your analysis on that level, but the political processes are carried out in only the administratively defined city, then these, can create, like the decision maker says, well, you're just counting everything that's out and around, and I have no authority over what's going on over there. This is my area just here. And so this is something that's an issue. One of the things that the JRC has been very successful in doing, working with UN Habitat, is basically getting their definition of urban agglomerations to be officially accepted in the UN system. So it's actually it's a built-up area definition. They use now it's Sentinel data to essentially map built-up areas around the world, and by doing that, they can define using both population density and in the built-up area. They use a combination of those two to come up with a new definition of what's the agglomeration. Exactly. Yeah. So if you look at Delhi, it's not going to look like Delhi administrative. It's going to look like Delhi. Yes. While no, I'm going to listen to you fully. Then I'll give you the demo right after.
Good morning, sir.
Good morning.
Sir, I use the data set that you mentioned like JRC, CDAC, and SMOD, but the resolution of the data sets are very coarse. So if I use the data set for small areas like micro scale for like small areas of Kolkata or like Sundarban, the coastal part of West Bengal. The result is not very fruitful because the data set is very coarse. So what your suggestion?
All I can say is I apologize, and that's something that I mentioned. There's going to be resolution differences between a global data set and what you can get locally. More power to you if you can get a local authority to give you, for instance, really high resolution LiDAR data. From what I understand, I don't know, but Dr. Rahman can correct me, you can't even obtain LiDAR data in India. It's costly, or the government authority won't give it to you. So now you're stuck with what? A DEM that's coarse. It's based on, well, the old it was SRTM. Now they have improvements, merit, DEM, other things. But these are all like, they're still not going to give you the same level of resolution as a good quality LiDAR. And the same goes for any of the other, urban delineation data sets. If you can get a better one, use it by all means, more power to you. But what we're trying to do on the global level, and this is speaking as someone who's really working on the global data front, is try to provide as much access to data as possible that can, fit the needs of a larger community.
What we do in that case, we scale up and scale down, because of the data resolution issue. So in that case, the only problem comes is the accuracy, and it cannot be matched with the other data which has better resolution. So at least we get some glimpse of it, what exactly is happening. So that is an issue. So the cost is one issue, and then analysis is another issue. So these are two issues. For that, you have to be smart enough and to have a very good system so that you can do that. Thank you.
So I'm just going to do really quickly a search. So what I did is I used that URL where you can currently access our data. The DOIs that we have associated with our data sets are not pointing, they point to a landing page, but you cannot download the data from that landing page at present. They're working, I think, on fixing that in NASA, but because they were pointing originally to servers that we maintained, they didn't feel they could point to those anymore, and we'll be decommissioning those servers soon. So they have all the data now in their NASA cloud. Let me just show you a couple of India data sets that might be of interest. Can you hold the mic for me? That'd be great. So you can put the mic right up to my mouth so I can. Sure. So what I'm doing here is, you see there's a search box. I'm leaving season in ESDIS. That's the term that was used by that URL that I already inserted. And I'm just typing India, and hopefully this will work. So for some reason, it's pulling up some data sets that have India listed, and somewhere so it's any data set that has India listed in the metadata, which is not all that useful. But I guarantee that if you keep scrolling through this, you'll get some data sets like this one, the India village level geospatial socioeconomic data set, and others like that that may be of interest to you. So I encourage you to explore those. I mentioned the SDG indicators. Those are all included in here. And so that's just to say that the data are accessible, but there's a few hoops you have to go through now. It's a little less user friendly. I don't know. Do we have time for one more question, or should we? Any more questions? We have one more hand in the back.
Good morning, Professor. My question is that you have earlier discussed about the public good and public bad, and the society that left the climate change due to the adverse impact. So my question is that if some people that are advantageous to the climate change, that are not prone to the climate change, and the society that are living surrounding those areas that are climatically vulnerable, if the advantageous population leaves that geographical space, then how can we see with the aspects of the climate change that that area is public good or public bad with terms of those people who are living around those areas? Thank you.
Thank you for the question. My reference to public good and public bad wasn't really about geographic space, but it was more about fiscal space, financial space. So what I'm talking about is basically when climate disasters occur, you basically there's two things that happen. One is you experience loss and damage, right? Because you have a loss of buildings, infrastructure, ports get affected, all that infrastructure that generates wealth could be either permanently put out of commission or temporarily where every day you're losing a certain amount of income. So that's the public bad aspect. The other public bad aspect is that if you start investing in climate, and I do believe in climate adaptation activities, but there's an element in which is a lot of those investments to make things more robust and more resilient are not necessarily productive investments. They're not actually generating a rate of return where you can pay the bank back, or if you issue a bond, you can't necessarily pay that back. So that's why it's a public bad rather than a public good. A public good would be like something like a highway. You build a highway, you expect commerce to increase, trade. You build a port, you expect things you're going to be like expanding your capacity to tax the income and the outgoing of that port. So all those things are public goods that ultimately generate revenue. The problem with climate-related disasters is they tend to be bads in the sense that they don't actually generate new revenue. They just generate losses. And when you invest to protect yourself against them, it's an investment that doesn't always return a benefit. It does in the long run in the sense that you avert future losses. Do you understand what I'm talking about? So then you talked about people sort of retreating. And we see this across the world, right? You hear about Silicon Valley executives buying homes in New Zealand, right? What are they doing essentially? They're saying, if the Earth is going to sink like the Titanic, I want my lifeboat to be somewhere else, right? That's essentially what they're saying. And so, Northern California might become, hit by a hurricane or devastated by wildfires, but I'll have a nice safe haven in New Zealand. And so, the point of this is that wealthy people know how to protect themselves. And so that by nature, they're going to find ways, and we all do it. I'm not criticizing. It's just sort of human nature, right? I'm going to make sure that me and my own are going to be safe if disaster strikes. We're going to have the best possible air conditioning system, and we're going to have backup generators and everything else necessary in order to, be able to survive let's say, a massive heat wave or something of that sort. So I hope I'm clear about that. Trying to distinguish the two things. Thank you so much. Oh, there's another hand, but I don't know if you have time.
Okay. Thank you, Professor Alex. Actually, I don't have a question, but a concern actually. Okay, as you have mentioned that about the US aid. Okay, as US aid is facing shutdown. Okay, despite its global humanitarian and development impacts, so it seems concerning. Okay, because various international commitments and partnerships are being adversely affected, especially the developing and underdeveloped countries. So, what is your opinion and what do you think about that?
I think it's tragic, and there's been a lot of reporting in the U.S. about this. So, I mean, I'm someone also who benefited from USAID. So I'm biased a little bit, right? I got funding through a number of years, over a decade. I was actually funded to go to Switzerland and work in IUCN headquarters by USAID to work on population environment issues at IUCN. Today, you could never do that, like even a decade ago, or, it would be too politically sensitive to fund someone who's at a high salary working at an international conservation organization. I think it would be considered to be wasteful and extravagant. Okay, so the point is that actually, I benefited from USAID. I also see the incredible work that it did in a lot of public health and other interventions, particularly, PEPFAR was a major effort to reduce AIDS. You had drug distributions in Africa that have been disrupted because of vaccine distributions that have been disrupted. And this has all been reported on. Clearly, USAID needed some reform. I'm not saying it didn't need reform, but to shut it down, I think, was a very callous So, one thing that people are saying is it's one thing to be America first, it's another thing to be hard-hearted. And then what we see is a hard-heartedness, basically, and that's all I can say.
Thank you, Alex. And I think this is another excellent delivery in the sense that the most important issue is not of the analysis and doing some work. The most important aspect, what I feel, is the data. And that Dr. Alex has deliberated and showed you what good data you can get freely without paying any penny. So I'm sure that most of our participants get benefited. Some of you must be using it already, but for most of them must be new thing, new insight from where all we can get. So earlier it was the satellite data that used to be becoming free and free in a free domain, but now socioeconomic data is also, and that thanks to the leadership of Alex and the other people at Season, they have started making the data freely available. Maybe 10 years back, Alex requested me, and I approached the Census of India, and we provided the Tehsil level data, census data of 2011, I suppose, and that was they tried to make what all is happening and what all the state of affair. So in that sense, this talk was highly useful, I'm sure, for the most of the participants. So thank you, Alex, for another excellent delivery. Uh, uh, it's heavy rain since 45 minutes or so. Very heavy rain. It's slow down. So I requested the guest house staff to provide the tea at this place. So tea is ready outside, so that most of you should not get wet in the rain. And then we'll come back in 10 minutes after that. And then I'll have my own lecture. Let's see. Thank you.